Now we're going to look at the power rule, and we're going to work with negative exponents. Here's where exponents open up a door into the rest of your math life, where there's way more than one way to do a problem. And so it's really important that you understand the vocabulary and the mechanics, because you can rearrange these just about any way you want, especially when we start doing more complex problems, and there's not just one way to do it. Okay? It's up to you to kind of pick it apart and see what you see first and deal with that. Okay? So if I look at this, I've got a number to a power to a power. And so what this says is there are 3 of everything in here. So our first layer of expanding is to write the 3 of them. And then when I expand those, there's 2 2's, there's 2 more, there's 2 more. So that I end up with 6 of those 2's being multiplied. So here I can do the same thing. 5 cubed, 5 cubed, 5 cubed, 5 cubed. And then we're going to write 1 2 3, 1 2 3, 1 2 3, 1 2 3. So when I look back, how many 5's do we have? 1 2 3 4 5 6 7 8 9 10 11 12. 5 to the 12th. Okay. Well, here, that's 7 to the 3rd power. Remember, there's really a first power here. So it's like saying 7 to the 1st, 7 to the 1st, 7 to the 1st, which is just, okay, same thing's going on. It's still 7 to the 3rd power. So let's look at this. How many of these x to the 6ths are there? Well, there's 1, 2, 3, 4. So I can go backwards and write x to the 6th to the 4th power. Now, what's our pattern that we're coming up with here? I had 2 and 3 and got 6. 3 and 4 and got 12. 1 and 3 and got 3. We're multiplying. So this is 2 to the 2 times 3. 5 to the 3 times 4. 7 to the 1 times 3. So here I'm going to write x to the 6 times 4, and that leaves me x to the 24th. I don't have to write all those out. Okay. Same thing here. I can write 3 to the 5th y squared, 3 to the 5th y squared. But then when I start expanding this, it's going to get messy. Okay? So I'm going to rewrite 3 to the 5 times 3. Y to the 2 times 3. I left one out here. 3 to the 5th y squared. There, now I've got all 3. Okay. This is certainly a lot easier to deal with, and I've got 3 to the 15, y to the 6th. Okay, and so here, a to the 6 times 12 is a to the 72. So we need to come up with a way to say what it is that we're doing. So when we're raising a power to a power, multiply the exponents. How is this rule different from the product rule? I want you to try to find the words for that, and that's something I'll be looking for when I check your flip in class. Our generalized rule, let's stick with a to the n, raised to the m. We're going to multiply those whenever we see that. Okay. So now we've got negative exponents. And again, we're going to follow the same kind of rule, right? Expand it, see what cancels. We got rid of everything. That leaves a 1 on top and the 3 on the bottom. But if I use my quotient rule, 2 minus 5, and I have to do these in order, the numerator minus the denominator, I get 2 to the negative 3. So I want to 2 to the negative 3 is the same as 1 over 2/3. Okay? Exponents are repeated multiplication, so when they're negative, they become division. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. When I cancel these, to simplify, that leaves a 1 on top, 1 over a 1, 2, 3, 4, 5 to the 5th equals, if I do a to the 4 minus 9, a to the negative 5th. Okay. Well, I don't have my original problem here, but I have the expanded form, and I can see 1, 2, 3 x's. So that's x cubed, 1y, 1, 2, 3, 4, 5, 6, 7 x's. So after everything is simplified, I'm left with 1y over 1, 2, 3, 4, x to the 4th. If I use my rule, the y's didn't change, right? So we're going to leave that alone. I'm not even going to write it down over here. But I have x to the 3 minus 7, x to the negative 4. Okay. This is already getting a little complicated to deal with. So we're going to do the a's. A to the 4 minus 9. B to the 5 minus 12 leaves me with a to the negative 5, b to the negative 7. So we're going to write 1 over a to the 5th, b to the 7th. 5 to the 0, that's just 1. 25 to the 4th, I'm just going to leave it. I could write down 4 25s. I don't want to do all that multiplication. We're just going to leave it alone. Okay. Now, there is another way to look at this, where I rewrite the 25 as a base 5, but that's going to change my exponent. If you come up with how to deal with that, we're looking at some extra credit. Okay. So again, if we're dividing, okay, we're subtracting, and then negative exponents right, they use division. So what if it's already division and it's negative? What's going to happen there? Well, what's the opposite of divide? 1 over 2 to the negative 3 is going to equal 2/3. Okay. So our generalized rule, a to the negative n equals 1 over a to the n. Or 1 over a to the negative n equals a to the positive n. Okay, we're changing back and forth between multiplication and division. It says do the opposite operation. Normally exponents multiply, so we're going to change it so that it's dividing. Here they're being divided, but it's the opposite, so we're going to change it back to multiplication.